Hi everybody and welcome to class. Did any of you hear the planes or anything? I didn't hear anything, so I guess it's because they really did fly just over the strip and not around where I live this time. So, anyways, today is going to be the last day that we talk about recursion. So, from now, in fact, we might even run out of time with recursion to things to talk about, and then maybe we'll do a little bit of linked list. But I dedicated the day to recursion, unless we just kind of not out of time, but out of ideas to do recursion. So I suppose that let's start with just coding a little bit of recursion, and then one of the things that I do want to show you is I want to show you another example of maybe like a recursive tree. And then from there, I want to show you some kind of algorithm that you can use to quickly convert something that is iterative into recursive and back. So converting code that does the same thing, but in iterative code and then recursive code. So does anybody know, or does anybody not know what a palindrome is? So a palindrome is a specific type of string that if you were to look at it, it's a mirror. It's kind of like a mirror. So for example, the word, what would be an actual normal word that we have palindrome? There's a couple. Race car. Yeah, that's a good one. Race car. So race car is a palindrome, right? And what makes it a palindrome is that if you read it backwards, it will be the same thing as forwards. As you can see, race car is race car, but also if you start from the end, you go race car. So you can see, you can read it in both directions. So basically it's like a mirror. So the center of this would be like the E, right? And then from there to the left is a C, and to the right is a C, and then A, and then R. So there is this sort of mirror effect, right? So I guess just to make sure that you're seeing that. If I do race car, hold on, let me rewrite that. Race car. I have an R here and I have an R here, so those are kind of like equal, and then the A's are equal too on both sides, and then C's. And then in this specific case, there's an E right in the middle, right? So palindromes can have a situation like that, where it's basically the everything is equal except for one letter, which is like the middle. There are some palindromes that are, and this, as you can see, is if you were to count the number of letters here, you have 3, 6, 7. So you have an odd number of letters, but you have an even number of letters, then you won't have anything in the middle. So anybody can think of another example of a palindrome? If not, then they don't necessarily have to be words. So here, let's just write something that would like not have any meaning but still be a palindrome. So like the word moon, and then like noom, I suppose. Okay, so in this case, we have an even number of letters, and as you can see, it's the same thing on each side. It makes it easier to see if you separate it like that. Okay, so this is like where you're splitting it right down the middle in these scenarios. Okay, so that's a palindrome. So I'm sure if you go on Google and type in like palindrome examples, you will see something that is like, there's like sentences that can be palindromes too. And sometimes, and obviously, if you put spaces, that defeats the purpose. So when we think of palindromes, we kind of cut all the spaces away. But some people will write like full-on sentences that are like palindrome. Here's actually a good one I just saw. Kayak. Yeah, kayak is one. So kayak is one that is like, again, wait, kayak? Yeah, that's right. Kayak is one that has, again, one in the middle. But here's one that doesn't have anything in the middle. Anna, right? Because that's an odd number of letters. I suppose lowercase, so that it's truly a palindrome. But yeah, there's a lot of them. Civic is one. And I found a link to a bunch of palindromes, as you can see there. So mom is a palindrome. That's a good point. Noon is a palindrome. Yeah. Rotor, that's a cool one too. Multiple word palindromes is more interesting. So like This one, was it a cat I saw? That's a cool one. So was it a cat I saw? So if I remove all the spaces and lowercase everything, then you will see that this is actually a palindrome. So like we have the W, then we got AA, SS, II, again removing spaces and lowercasing. T, then we got the two T's, then we got A's, and then we got a C right in the middle, right? So that's actually a more fancy one. Other ones, for example, no lemon, no melon. And then red rum sir is murder. I think I've seen that one before. But anyways, so the question I pose to you is, yeah, it's interesting. So the question I pose to you is, can we develop a function that can check whether a word is a palindrome, both iteratively and recursively? So of course we're going to start with the recursive one, but then, we'll see if we can do it iteratively as well. And so we're going to make the assumption that it's already been pre-processed and cleaned up, which means like we're going to remove all upper and lower cases and squish all the text together. So in that case, for example, the was it a cat I saw, everything's going to be lowercase and put together. And then I guess the no lemon is no melon or something. No lemon, no melon. And then let's put some that are not, just so we can see if this works or not. So let's say, was it a dog I saw? Okay, how about that? And then another one that's almost a palindrome, but it's not, like a race car, like that. But maybe let's throw in like, well, that would be a palindrome too, but let's do it like that. Okay. So anyways, we got to put in some variable names for this, so we'll just call them A, B, C, and D. How about that? And E. Okay. So the function that we're going to use is going to be called isPalindrome. Palindrome, and we can make it a Boolean returning function, so it returns a Boolean that represents true or false, whether it's a palindrome or not. So we'll just kind of see out is palindrome A, for example, and do that for all of them. So we'll say B, C, D, and E. Okay. So now all that remains is, of course, the biggest part, which is making the function. So as I said, it's a Boolean returning function, and Booleans are part of C++, so we don't need to include anything. Whereas in C, they're not. In C, you gotta include like the bool header, I think it is. I don't remember, but it's a header you have to actually include, so you can use Booleans. Of course, you can work around that by just using an integer and checking if it's 0 or not. But yeah, so. That's technically how C works. So the parameter is going to be a string, which is the string that we're going to check whether it's a palindrome or not. And how about we start with the assumption of that it's not a palindrome, or how about that it is a palindrome? Yeah, we're going to start with the assumption that it is a palindrome, and then we are going to check it until we find something that breaks that rule, and then we'll return false. We'll set it to false. Okay, so we're sort of going with the innocent until proven guilty approach. Okay, so we're going to say, okay, we're going to assume that this is probably a palindrome, and then we're going to start checking it. If at any time something breaks it and it's not a palindrome, that's when we can stop. Now, if we go and look at the way that I was looking at things, you can see that I'm comparing the last and the first characters, right? So like, if I want to check if something is a palindrome, for example, for Anna, I got to look at that and match it with that. And as long as those two characters match, then so far it's a palindrome. So I can go look at the next two characters, right? Which will be the N and the N. And if those match, I'm still okay. If at any time, however, say I was looking at the word and. In this case, if I match an A and an E, that's when I should stop and be like, hey, this is not a palindrome because those don't match, right? So that's kind of the approach I'm going to take. The answer is spelled different first time. Oh, thank you. Yes, it is. So if we're doing this recursively, what we can do is divide and conquer. So we can say in each pass of the recursion that we do, so each recursive call, we're going to check 2 characters and make sure they match. If they match, we continue checking. If they don't match, then that means, that's it. It doesn't matter. We don't need to check the rest. We can just return false, and then this pretty much can be done, right? So that's pretty much what we're going to do. So we're going to say, okay, the function's job is just to check 2 characters, and then call the function again on the next 2 characters to check into the inner string. Now, there is one special case, which is that center character, right? So we want to check the center character to make sure that we're matching it with itself and you don't like crisscross. Like, for example, if you're looking at this and this, and then you're looking at the next 2 characters, which would be the A's, and then from there, you want to make sure that they're both looking at the same Y, but that's also the sign that you should probably stop. I mean, you could still keep going, but it would be pointless, then you flip the arrows around. You'd be looking at the A's. So you want to make sure that you have a way of stopping it. So our base case is going to basically be when both characters we're looking at either point to the same thing, or in the case of something with an even number of characters, that they basically crisscross the arrows, right? So we start, for example, with this one with an even number, then we go look at the ends, and then the next thing we do is, again, they would like crisscross. So like now we're looking at the ends again, but on different sides. So when that flip happens, that's again the sign that we stop, okay? So that's going to be our base case. Now, as you can see, we're going to be looking at 2 different spots in the array, and those spots are going to be updated every time we call the function. So, as parameters, because remember, recursion is cool and all, but it's like a guy with amnesia. What is that? I had like a pop-up on the tablet. Hold on a second. I think the iPad like updated or something, and like popped up things like, would you like to try out the pencil? I'm using the pencil right now. So anyways, but yeah, so recursion, recursive functions are like somebody with amnesia. They don't remember anything from the past time that they basically activated. And so, normally when we're printing out something like an array, recursively and whatnot, we have an index we keep track of here. In this case, we're going to have 2 indices that we're keeping track of, which is the left and the right thing that we're comparing. And between the function calls, we're going to have to update and pass those again to the next recursive call. So in addition to our string, we are going to have to add those 2 indices. So we can call them left and right. And initially, the left and the right, the left initially, the first time we ever call it, is going to be pointing to the farthest left of the array of the string, which in this case would be the first character, right? Which is found at spot 0. The right one on the other side is going to be pointing to the last character of the string in the first time it runs, right? So while I think we can actually do this as a default parameter, for now, just for now, we're going to go ahead and manually throw them in here, okay? But like I said, I think I can make that a default parameter and then get away with that. So like what I'm saying is the left always starts at 0. That's a given because the first character of every string is always at index 0, right? But this one's the one that's going to change, and it would depend on the size of the string. So like we can actually use a function for that. We can say str size, and then that would return it, right? In fact, well, actually, let's just do it like that, so we don't have to update every single one of these. So yeah, so even though you don't see parameters here, what is happening is the first time we call this, it's going to call it on 0 and then the index. Although technically speaking, that index is the size, so we need to subtract 1 from that to make it the last character, right? Because if we have an array of size 5, it's an indices 0, 1, 2, 3, 4. That's where the 5 is. For example, for Anna, the indices are going to be 0, 1, 2, 3, but the size of the array is 4. So when we compute the size of the string, it's going to return 4. But what we wanted to point to in the beginning is the left side should point at 0 and the right should point at 3. So just take the size minus 1 is how I get 3. So that's why there's a minus 1 there. Okay? So let's just make sure that this compiles. Right now, of course, it's going to return true for every single one of these, assuming that I local variable may not appear in this context. Ah, okay, so it's not letting me call this because it's here. That's unfortunate. So I guess in that case, I will have to add 1 parameter to all of these. Let me flip the left and the right. It's going to be counterintuitive. Oh, yeah, okay. I don't want to flip them because then it's going to be counterintuitive. But that's unfortunate. If I would have to flip them because it's a default parameter, but I want to keep them in that order. So I guess I'll just have to pass in 0 to all of these. And then a dot size minus 1. That's unfortunate that we have to do this like that. Can I get around that error somehow? Probably not, because of the way it has to know the size of how much parameters. No, but it does. I don't know. I don't know if there's an easy way. I have an idea, but it's more of a hack. What I could have done is I could have made right just like, doesn't matter what. Maybe actually make it like a negative number. Can't you do it with the semicolon at the end? What do you mean with semicolon at the end? Are you talking about like the actual colon, like initializing a class variable in the class? Here's what I'm thinking I could have done, and this would have actually worked, but it's just kind of weird and might confuse you what we're doing. I could have set this as a default parameter to like -1, and then I put an if statement here saying if right is equal to like -1, then go ahead and set it to the size of the string. Something like that. This is something I could have done, and in fact, I'll probably do that, but not yet. I will do it at the end after we finish this, just so you can see that that actually would have worked nicely. Okay? But I could have done that. As for what you're saying, I don't think you can do that in a non-member function. But here, let's try it. I don't even know. No, I don't even know what like the syntax for that would look like. Let's see if this works. I don't think that. I think that's strictly reserved for class members. Yeah, only constructors. Yeah, take initializers. So this is called initializers here, and apparently, it only works when you're using it on a constructor in a class setting. So like, we have a class A, and you have your A constructor, and this class A has like an int x in it, and you're writing your constructor for A, and you take a parameter here. We'll call it like bar. And then you put the colon, and then you say x gets the value of bar, and that's how it gets initialized. And then you do whatever else you want to do here. That is okay. This is called initializer list, but this is only a thing that works for like constructors. It does not work for a normal function. So it's a good idea, but that's not the C++ developers chose to not allow us to do that. So yeah, just like they didn't allow us to do that with that parameter there. Anyways, but don't worry. That idea that I thought about with the if statement and the -1 will work for this, but we won't do it yet. We'll just leave it like this for now, because then we'll upgrade it. Okay. Plus, it's a little bit more intuitive when you see it this way, actually, with the numbers that I have to pass in by hand. Okay. So, anyways, if we compile and run this, it should be okay now. I mean, it doesn't do the right thing, but it should just print out true to everything. Okay. Something I found out is it might be a good idea to add an end line somewhere here, so maybe here. Yeah, okay. So now you can see a bunch of ones. Each of these ones represents whether these return true or false. And right now everything's returning to true because we hard-coded it. But that it is. It actually works out that they're all in the same line because it's easy to see. Okay? So now we just have to actually add how to actually run this code. Like how to actually check if it's a palindrome or not. So as I said, what we want to do is we want to check the left and what the right is of string. So remember, I guess a refresher, that a string is nothing more than, well, it's nothing more than an array for you, but internally there's like stuff going on. It's a little bit more advanced than that. But, you know, at our first sight, which is all we care about, I can access any member of this character array, which you can think of it that way, by just putting an index. So if I say something like cout str0, that's going to print out the first element of this array. And similarly, if I said str and then the right, so left, actually let me leave left in here instead of 0, and then right, that's going to print out the last element of the array. So that's all I want to do right now, just to prove to you that that works okay. Of course, it's going to print it out a bunch of times. Actually, no, just one time. Oh no, a bunch of times because I have multiple function calls here. But you can see here that it is indeed printing it for the race car, and then for the was it a cat I saw, and then for the no lemon no melon, and then for the was it a dog I saw, and then for the race F car. Okay, so you can see in all scenarios it does match the two letters together, and of course the ones are intertwined, right, because of the order of this is being called. So anyways, we know that this works, this whole couting part. So now all we need to do is compare them. We need to compare the two things. So we can say str left, str right. And if they're equal, well, we want to store that answer somewhere. So let's store that answer in our answer variable. Okay, so if they're equal, we're going to get a 1 back. If they're not equal, we're going to get a 0 back. Let's actually add one more case here, where like the first letter is just totally not equal. So like raw, right? Raw is a good one. Okay, and then let's throw it in here as well. Oh, I put it inside the function. Okay. So now, if I run this again, should there be an equal on line 7? Ah, yes, there should be indeed. Good catch. So we're basically storing that comparison in the answer line, okay? And you'll see that this can be simplified a little bit. We'll do that at the end as well. We don't even need a Boolean created. We can just return directly. But for now, as you can see, it returns true for every single one of them except for the last one. The last one is comparing the raw, the R and the W, which is not true, and it returns a false. So this is working so far for at least comparing the first and last character. Okay? The next step is we want to take that answer and combine it with the result of checking the next set of characters. So how can we do that? Well, we can take answer is equal to answer and, because it's logical, and the remainder of the string that we need to check. So like we checked A and Anna. Now we want to check the N and N. How do we check the N and N? Call the same function again on the same string, but this time change the indices you're passing it on. So the left, increase it by 1. So instead of 0, you check spot 1. And now instead of comparing it with spot 3, you check it with spot 2, which means you got to subtract 1 from the right, like such. And so now this is going to take the answer to this part and combine it with the answer to our part. And basically that is going to get us the final answer. Okay? Now, we have thrown in recursion, but we haven't thrown our base case. So if I actually run this right now, you're going to see bad things are going to happen. Actually, bad things didn't happen. Interesting. I do wonder what went down and why it didn't crash. Let's see. But here, let's look at it. So it looked at the R's. It looked at the A's. It looked at the C's. It looked at the same E's again. So it's looking at the same E. Then it's going back and looking at the C's again. All the way until it gets to the R's. And then you get this random V. Which who knows where that came from in memory. That's just literally a random V that came out of nowhere. Yeah. So this is actually quite interesting. Oh, I know what happened. Oh, this is interesting. Oh, this is actually really cool. Okay. Does anybody know? I figured out why. But like that's interesting. This is kind of cool. I wonder if I can actually edit this slightly to fix that weird V coming out and still have this fully functional. But does anybody know, even though it's really hidden, there kind of is a base case as it is right now. Does anybody know as to why this didn't keep going forever and why it actually stopped? And it's something you learned in 135, and it has to do, well, like with this line. It has to do actually with this guy. Think about it. Well, you guys think about that? I want to see if it worked for the other ones. So we get the W, was it a cat, was cat, and here we go. It's going out of bounds there. So it's matching this out of bounds thing with some other out of bounds thing, which does not even appear here, which is interesting. It doesn't appear. Interesting. Okay. But yeah. It does go out of the array length, and it does indeed. But do you know as to why this is not recurse forever? Because think about it. This should have gone forever. Like, it would have gone like this, crisscross. And right now, when it goes out of bounds after the string ends, it sees that there's not a match between the two garbage values, and then it stops. But why does it stop and not keep comparing garbage values? When the answer is false, I think the ampersand sees that as one of the operands false. Yes, you are indeed correct. Yes. So that has a name in C++, and that name is called short circuit evaluation. This is like a really nice review of 135 by accident. So short circuit evaluation is exactly what you're saying, and that's the reason why this doesn't recurse infinitely. Short circuit evaluation is basically that C++ is lazy. It doesn't want to do more work than it needs to. So when it looks at a logical statement like AND, if the left side, which it goes from left to right, so first it checks the left side, which in this case is this variable, and then it checks this side. So when it looks at the left side and it evaluates that to false, it knows that it doesn't matter what happens on the right side, because it already has figured out that the left side is false, and false and something, like literally logical false and something, will always evaluate to false, whether it's true or false, right? Because false and false, like if I have false and false, that always evaluates to false. But if I have false and true, it still evaluates to false, right? It's only with the logical OR where, like, if one of them is true, then the whole thing is true. So like if this is logical OR and I have false on the left side, this could still be true, and I need to look at the right side. But with logical AND, you don't. And so that's exactly what's happening here. When this thing goes out of bounds and it compares the left side and the right side, and the left side is probably some like out of bounds value that's invalid, and then the right side's probably the same thing, out of bounds as well, it basically sees that that this is false, like these things don't match. And so when it sees false here, it doesn't even bother calling the function again. So yes, that is correct. So that's actually like, wow, it's pretty surprising. So if I was to flip these around, then you don't have that sacred evaluation nice thing happening. And so now it should recurse forever, basically, until it seg faults, as you can see there. Okay? Here, let me hide that, so you can see it in its full glory. So what is happening here is that it starts looking at race car, or any of, it never gets past race car. So it starts looking at race car, as you can see here, and it just like goes race car, goes through, checks the other parts, and then goes out of bounds of the array into like infinity in memory. And it's just comparing like garbage in memory, as you can see. Now I do find it very interesting that it has race car multiple times. So like my only guess as to why it goes back and sees race car again is that, like, I don't know. It must go all the way to like where like overflows the integer into like a negative number and then comes back or something. I don't know. Yeah, it's just weird that you see race car multiple times. Yeah, but anyways, as you can see now, we actually got what we expected this time, which is a good old segmentation fault. So, while this is cool, the short circuit validation thing, and I could still use this as my base case, there is one thing that I do need to do up here, which is what the real nicer looking base case is going to be. And that is that I basically want to make sure that if the left is greater than the right, I'm done at that point. And if I'm done at that point, I can just go ahead and return true. Now, why return true there and not false? Because if I return false there, the whole thing will break and always return false. I'm basically saying I'm done in the array, and so I haven't found anything that has broken it, you know, any non-matching characters. So I just want to keep going with that. I'll just say like, yeah, I mean, you know, they crisscross, but that doesn't mean that it's wrong. So I'll just return true. I wrote false even though I just kept saying return true. Okay? So what this is saying is when I got my two indices and I'm checking either the same character in an odd number of letters, or I crisscrossed and I'm checking like this, that's my sign to stop. Okay? Technically speaking, when I'm pointing at the same one, I'm still checking it. But if I go ahead and just say equals here, it doesn't make a difference. Both work, but this one's, I guess, more efficient because I don't need to compare the same letter with itself. I'll leave it off now so we can see it print out that same letter, actually. But both will work the same way. And that's pretty much my base case. And now, I mean, I think this is done at this point. So let's clean it up so we can see it better. As you can see here, it looks at the R's, it looks at the A's, it looks at the C's, it looks at the E's, which is the middle one, and then it decides that this is indeed a match. Now, just to put it side by side, if I make this equals here, then you wouldn't see the E's print out in the center. As you can see here, it checks the C's, that are these two C's right here, but then it doesn't check the E's because it's just looking at the same one. So as I said, this is slightly more efficient, but both work the same way. Okay, looking at the next one, that one is all the way here. So it says the W's from was A, the S's, the I's, the T's, the A's, and the C's. Was it a cat? Was it a cat? So it doesn't look at, Oh, okay, it's the top one because it's looking at the equals. But the bottom one should get rid of the C's. Yes, it does. It doesn't check the C's here, as you can see. Next, we look at the no lemon melon thing. No lemon, no melon or whatever. As you can see, it checks every single letter and then returns true. In the version where it doesn't check the last center, in this one, I suppose it's even for both of them. So there is in the center letter, so they both look the same. The next one, so we go into the ones that are not palindromes. Let's see if it actually detects those, because it's important too. Otherwise, yes, we could write a code that always says true. And that is, was it a dog I saw? The W's match, the A's match, the S's match, the I's match, but the T and the G do not match. So basically, from the I here and the I here match, but then when it looks at the T, which in the past one it matched with a cat, but with a dog it matches with a G instead of the T. And so then bam, that's not a match. And notice something, it doesn't keep checking. It immediately stops, returns false, which returns false again, false, false, false up the call stack, and basically terminates the program. So with a false. Or not the program, the function, the main function. The original palindrome function, not main. A C out on end line on line 6 before the return may be nice. If I put an end line there, I'm gonna get a line feed after every pair here. So like these will all have line feeds, like line feed, line feed, line feed, line feed, line feed, and so on. Where I could put it would be here, like you were saying. Yeah, I guess why not? We could put it there. Okay. So yeah, it kind of works, but then we have the number on the wrong line, which looks weird. So I don't like that too much. If I really just want to add line feeds between them, I can just do that here. And then that'll take care of like making it look nicer. Because otherwise the numbers are not in the same line. Yes, exactly what you said. So anyways, but okay. In this scenario here, as you can see, the T and the G don't match. And then for the race F car, the R's match, the A's match, the C's match, but the E, F don't match. Right there. There's one too many letters in this palindrome. And then raw doesn't match either in the beginning. So yeah, that's pretty much it. So as I said, the last thing I want to do here is I want to do, switch it again so we don't have these weird parameters being called. So the first thing I'm going to do is I'm going to set left to be 0 as a default parameter. And then I'm going to set right to be -1. And that's just an arbitrary number. I could have picked 0 there too, actually. But in fact, yeah, there's never a scenario where right could be -1. Okay. So now if I do that, I can basically call this with just the letter. By the way, there is something I just remembered I wanted to bring up. We have talked about recursion and mostly just stuck to the same function, calling the same function again. But there's also recursion. We'll come back to this in a second before I forget this. There's also recursion that is like indirect recursion. So like suppose I have a function foo. That inside of the code of foo, you have a function called to bar. And then in bar, you have a function called to foo. Somewhere in the code. There's other code, but you have something like that. So then if in main, you have a function called to foo, this is going to potentially recurse infinitely if you don't have base cases, right? Because that's going to basically call this, which will stop and call bar, which will stop and call another instance of foo, and you'll keep going. It's basically like playing ping pong back and forth, right? So this might be unintentional if you're coding stuff and you don't realize that. So you have to be aware of this. You typically don't want to do this unless there's a reason. But if you are doing it, you want to make sure that both of these functions have good base cases that stop this when they should. So just FYI, that might be a thing that you could run into. And I keep forgetting to mention it, so better mention it before I forget again. So anyways, that's what just happened here though, but it's good to know. So anyways, how I'm gonna fix this for the initial call is I'm gonna add an if statement here saying if right is equal to -1, then I'm gonna hard code it to say str.size -1. And if I do that, this should work the same way now. Line 6, forgot a semicolon. And there we go. Pretty much works the same way, but now the function calls look nicer. They look cleaner. And it's just kind of a tiny little hack, right? Obviously, I can break it if I'm malicious by passing in a negative number here, for example, or passing in -1 there. I could break the function that way. I'm not saying this function is like perfect, but you know, it's okay. It's good enough. I suppose if I want to add one more extra check is that if the left is passed anything that's negative as a starting value, that's bad. Or if right is passed anything that's negative, except for -1, which is a special case, it's also something that's passed bad. We're just assuming that we're going to pass it valid information. So, however, if you want it to be super safe, something that I typically see done often is, and this happens more with linked lists, is you could always have something like this. Especially if you're working in object-oriented like design. You could have sort of a generic function. So let's say we had a class that has like our library, right? So let's call it CS live or something, CS library, right? And in that class, you actually had your Boolean function is palindrome. You would make that a public function so that people could use it, but that wouldn't actually be the function that does the checks. That's just kind of like your front end function per se. This function, all it does is error check, pre-process data, whatever it needs to do, prepare it, but primarily just error check, and then calls like another function called like return internal pal, and then the same parameter. And then that's just another function here, but this one's private. And that one's the one that actually does the work. So that one is actually like the real palindrome checker. But the reason you don't let people call that in the beginning is because, you know, you avoid problems like this with the default parameters and whatnot. This function does not allow default parameters, whereas is palindrome might, but it does error checking for them, or it doesn't have any, it just passes a string and it handles that. So we can do something like that. So let's go ahead and implement that. So let's say we're putting in this function in there. And then this is going to be called the internal one. So we'll say int palindrome, or is, actually no, leave it as is palindrome, but we'll call this 1. So this one's private. That was a private function right there. But then we're going to make the public one. That one we'll just call is palindrome. And it takes a string. So this one is the one where you can do all the error checking you want for it. And then as the last line of code, then call the other function, like is palindrome 1. And pass in the right values initially that are for sure the safe values. This will prevent the user from doing bad things to the code, essentially. Like that. So what kind of error checks you could do? Well, suppose they pass an empty string. I don't know if we consider that as a special case. In fact, we can find out. In fact, what if they pass just an undeclared, like just like that, and then, sorry, for a second I couldn't remember one went after G. It's like, what letter goes after G? All right, so let's call this 2 more times. So this is a good thing to do, not just for this, like for this scenario, but in general when you're working with object-oriented programming. You have a function that is like doesn't necessarily do any error checking. You can make a private and then have a public function that does all the error checking, and then calls a private function to actually do the computation. What the advantage of this primarily is that you separate functional code from error checking code and allow the function to be much easier to maintain. Like, if there's a bug in this function, you can check that issue without having to worry about, error checking or weird hacks like this. So we can probably get rid of this weird hack, and put it down here. Or the weird thing about the default parameters, we can get rid of that as well. There's a lot of things we can get rid of now because the user no longer has ways to mess with that. And again, this is not hacker safe or whatever. It's more like to prevent accidents, because that's really what you're doing here, is preventing accidents, like bad coders from doing bad things. Like, you don't trust the people that you're going to use your code, essentially. So anyways, I'm curious now to see if G or H are going to cause issues the way we have it now, because then we can use that to error check those kind of weird scenarios. Oh shoot, I gotta make it. Okay, I'm gonna go ahead and just make this static so that I can, because it doesn't really have to be associated with any object. And now I can just go ahead and call it, so cslive like that. Okay, so it seems that as it is now, our code, we don't have a problem with the empty string. That just returns that it is a palindrome, which I suppose it is, technically speaking. But if in your definition of a palindrome, the empty string, and by empty string I mean literally like nothing in the string. If by definition, if you wanted that to not be a palindrome, you can make that special exception here in this function. And for this one, nobody knows what is in G. It's garbage. That might return true or false depending on what's in G. I'm assuming it's initializing it to the empty string when you declare it, but I'm not 100% sure. So nobody knows. Big mystery. But anyways, you can do any potential error checking that could happen with this string. At this point, there shouldn't be any because you don't let the user passing any indices. But if you had anything you wanted to add in here, you can add it here. So add any error checking / pre-processing before calling function. Okay, so this is a good technique to do. So this is just an example of that. Okay, so this is cool, but how do we do this iteratively? And so before I show you this, I would like to show you this basic sort of conversion algorithm between iterative code and recursive code. And this works in both directions, okay? For not everything, but for a lot of the recursive code you write, this can work. And for the ones that it doesn't, then you can use a stack, which when we talk about stacks in about 3 weeks, then we can come back and revisit this sort of conversion thing. And I use a stack to show you the rest of them, okay? So normally, recursion consists of the following. You have your function call, or your function definition. You have your parameters, and you get your body of the function. And you typically start out with a base case, which is usually something like if param, and then compare that with something. So I'll just put that line to mean compare with something, and then some value here. So if you're comparing these two things, then you typically do some sort of return, okay? Whether it's value returning function or not, you return something there or just call return. And then if the base case is cleared, that means that you gotta still go with the recursions. So then you have your recursive case, if it's head recursion, or if it's tail recursion, then you have something before that. And that's basically some code to get you closer to your goal. To get you closer to goal, okay? So that would be if it's tail recursion. Alternatively, if it's head recursion, then that goes beneath it. So that is the only difference here, okay? But this is basically the way pretty much every single recursive function works, using this sort of format. So we can exploit this idea and convert it into iterative code by just kind of following this sort of formatting. So the first thing is we can mimic the power of recursion with a loop that is just going to run forever. So we can say while true, or just while 1, and that can be sort of like our function. And then for our base case, we can do the same thing. In fact, let me copy and paste this. Here. The base case, when it comes to iterative code, is going to be the same base case that you would have in recursive code. The only difference here is that instead of a return, you're going to put in a break. And then if there's a value that you want to return to, so if that will work if it's a void function. But if it's a value returning function and you want to actually return something out of the function, what you can do is you can have a variable outside of the recursion and then, save that to var before you break. Whereas here, if it's a value returning function, you can just say like return A or whatever the value is that you're trying to return. Here, you can just copy that to the variable outside called var or whatever variable you want. As for the recursive case, the code, well, first of all, let's look at the code to get you closer. You still have that in the same spot. You could have, you kind of have to have it as head recursion in this case. Otherwise, it doesn't work. If it's tail recursion, that's when you're going to need a stack, which is the one we revisit. But if it's head recursion, it'll work the same. You don't really need a recursive case for the while loop because that's what will happen automatically. What you do need, though, is you need to, something that you're doing in the recursive case here is typically two things. You're updating parameters, and then you're calling the function again, right? So like in our case with the palindrome, the parameter update is increasing left by 1 and decreasing right by 1. We are doing that directly in the function call, but I could have just as well written a line out here that said left is equal to left plus 1, right is equal, or right minus equal 1, right? That would be the shorthand, I suppose. But in this case, I've done it together, right? I squished it. But here, let's take one of them out just so you can see what I mean. So I can say like right equals right minus 1. And then in this case, I can just go ahead and pass right like that. Okay? So I can do my parameter update outside of the function. I don't have to, but I can. Of course, doing this saves me time, but makes potentially... I would disagree. It doesn't make it less readable in this case, but it might in some scenarios. So you have to be careful about that. So anyways, here, that's really what the recursive call is. It's two things. You're updating your parameters because, again, amnesia, and you're calling the function again. In the iterative version, you don't need to call the function again, but you do need to update your parameters. So that's really the only part of the recursive call that you're going to have is just update parameters. And that's it. As long as you do that, you pretty much will have working iterative code. Now, let's apply it to this example here. So in this example here, like that, we have our base case. Let's just get rid of this for now. And then let's... yeah, we can trying to get rid of as much as possible for now. In fact, here let's write is palindrome 2, which is like the cleaned up version of this code, the smallest possible. So in that one, we don't need to have this. We don't need to have that. We don't need this. We don't need any of the cout statements. And then, by the way, this whole thing here could have been made a lot simpler, by the way. by basically saying return this, and it with this. And then we basically get rid of all of that. I didn't do that earlier because I didn't want to make it confusing, but yeah. But let's make sure that I am not wrong and test it by just switching it so it calls the second function instead. So there's that, in case you can't see that top right there. But yeah, let's test to see if this runs. As you can see, it is working the same way as before. Let's see, yes. Why is he still printing stuff though? It shouldn't be printing anything at this point. It's Palindrome 2. Why is it still printing stuff? That's strange. String str2 if left is greater than right. I don't know why it's printing stuff. That's strange. Where are these letters coming from? Is palindrome, is palindrome, is palindrome, is palindrome. String cout and line. Return is palindrome 2. Static bool, left is greater than right. Oh, I see why. I forgot to put that right there. So it was calling the first function and then calling the second function. So yeah, okay. There we go. So let's see if it matches. So from the original one, it says that this is palindrome, 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 and then not a palindrome, which is not a palindrome, which is not a palindrome, palindrome, palindrome. So okay, so the function still works just fine, except this is like the really nice clean version of this function. As you can see, no cout statements, and I got rid of the Boolean answer because, as you can see, it's really just a temporary variable. Like I set it to true initially, and then I save it to whatever left and right, or you know, if they're equal or not, and then I take that and I AND it with the rest of this. Instead, I just basically made it all one big line of code. This is something I don't recommend you start off initially with. Start off with this method, get it all working, easier to debug that way too. Once you know that it's all working, then you can shorten the code if necessary. Although an argument can be said that it's not always the best idea to shorten the code because it makes it hard for others to understand what the code is doing. If I showed you this initially, you might have been confused as to why this whole thing works, whereas showing it this way is a little bit easier to see each step. But anyways, I made it into this format so that I can make the while loop version easier. So let's go ahead and write one more function, but this time let us go ahead and write the iterative version of this palindrome using what I did here. So let me, so you can see this here. Let me make that smaller, like a little bit smaller so I can zoom in. There we go. I think that works out. Okay, so it's still going to be the same parameter. So my goal again is going to be, instead of calling palindrome true, I'm going to call palindrome tree, which is going to be the new function I make. So it's still going to be a static. In fact, let me just save time by copying the function here, but removing the, I don't actually need left and right in this one because it's the iterative one, so I don't have a problem with that. Although, so I don't have to change the above code, I'll leave it actually. So I don't have to change this call, okay? But yeah, I'm gonna overwrite them anyways, just so you know that left has a 0 in it and right has the str size -1, which is exactly what they have already, but just so you can imagine that those are not there. I'm only leaving them so that it's easy to change back and forth between 1s, 2, and 3 by just switching there. But yeah, okay. So anyways, what I want to do here is I want to start out by saying, well, actually create that var variable. I don't know if we're going to need it in this case, but just create it to be safe. And then create your infinite loop. Now, I'm not saying, here's the thing. this works for converting recursive code to iterative code. Now, I'm not saying this is like the best way to do it or the most efficient way. Just like how I cleaned up this, I can definitely clean up the other one as well. This is just as a quick way to get you going once it's switched. But after it's switched, it's never a good idea to have an infinite for loop or infinite while loop in there anyways. But it's a good start because the next step here in the sort of conversion from recursive code to iterative code that hopefully you already kind of saw ahead of time is that I will eventually want to actually move my base case check, this right here, into the while loop check. And that will pretty much do the same thing as having it there. So like this will be sort of like the V2 of my code. I can move the base case check into the while loop check because it's the same thing. And then I do have to do something to it. I have to flip it. Because before, if that evaluated true is when I wanted to break out. But now, if it evaluates true, I want to keep going in the loop. So flip it with the exclamation point, and then it works okay again. Right? Because in this case, if it evaluates to false is when I want to break out of the loop. So that, of course, is, I suppose, the next stage. But we're still doing the top one, okay? So anyways, I just don't want you to think that this is like going to look really good. Because the fact that we're putting an infinite loop is already like, oh. If I saw somebody's code, I'd be like, yeah, I hope there's a good reason for this. So anyways, let's start with that base case then. The base case is, of course, going to be the same thing as the recursive one, which is this case here. If the left is greater than the right, return true. In this case, however, it's a break. And as I said, you can make your var equal to whatever you would return otherwise. So in this case, var gets true. Okay, that takes care of the base case. Next is the code to get you close to your goal. In that case, the code to get you close to my goal is comparing whether the left and the right are equal. So in this case, I can go ahead and compare them and then basically update or as I have it before, create a variable, a temporary variable that that would basically, you know, keep track of that. So let's call that bool answer and store that in there as I had it before in this top one. And then from there, I want to update my parameters as it says right here. Laser pointer. Right here. And then run it again. Okay? So here's where it's gonna slightly change. Okay, well first let me update the parameters. So left plus equals 1, and then right minus equals 1. This of course is like shorthand for right is equal to right minus 1. Okay, so here's the catch though. This is where you slightly gotta get a little bit creative. You only call, like, you call the recursive function to find out whether these are okay or not, but you need to AND that with what you currently have now, right? But this information is not information that you have yet, because you need to AND it first to figure out, but you need to know what that is equal to, okay? So in this case, what you need to do, and this is where it gets a little bit creative, is you have to say if answer is, just say if not answer. So if answer is false, then you want to break out. But before that, set bar to false. Okay? And then now, just go ahead and return bar with your actual answer. So that's what you basically have to do. So this is the only part where you have to think about as to the why I had to do that is because I am ANDing them together. So in that case, you want to stop checking if otherwise you keep checking forever. Alternatively, what you could do is you could store that in a variable and then put that in the base case as a check, but that would be weirder. So yes. Anyways, let's test it to make sure that I don't make a mistake. Cannot be overloaded. Okay, I forgot to change that to a 3, I suppose. There we go. Okay, there we go. As you can see, it is all working the same way as before. Yep, so it worked out. But now there is no recursion. So I highly doubt this is going to make a difference at this point. But if I time it a couple of times, yeah, it's too little of a timing. But let's do the recursive one and see if it slows it down. Nah, same speed because it's too few of these. But if I and most of the time is actually is probably spent outing stuff. But if I put this in the here, try this at home. Take this code, get rid of the out part, I suppose, or even if you leave it, store it in a variable, like in an array, and then actually no, get rid of all the outing, and then just like put this in a for loop that runs like 10,000 times, and then time the code with palindrome true and then with palindrome tree, the one with the recursion and one with the iterative. You run it like that, you should see a difference in the recursive code being slower. And by the way, whenever you want to time code, just write the word time in front of it like that. Yes, the time argument shows how long it takes to run the code. Yes, so you see three numbers when you run it. You see real, user, and system. If I remember correctly, the real time is almost a combination of these two, but sometimes you will see that they don't add up. That's because they can be running at the same time, sys and user. System is like internal stuff. User is like how much your program actually is taking time to run. So yeah, as you can see here, they don't really quite add up, but that's because it's a really small number. So it could also be that if you're running other programs at the same time and your computer is slowing down, the real might be big, but that's mostly because like other stuff, not because of this program, which could be a sign here as to why. Because as you can see, both the program itself takes way less than the milliseconds here, but the fact this took longer is probably because there's background processes going on in the computer. So, but anyways, yeah, if you run this big enough, you would see that difference, that recursive code is slower because of all the function calls and whatnot. But anyways, last 3 minutes, let's clean this code up and make it look nice. So let's do one last version of this function. So this sort of basic conversion idea is good to get you going to switch over. But when we talk about stacks, we'll come back and revisit this and make it more formal, because then we'll have a way of fixing that issue as well. So anyways, to clean this up, what I said is take this if statement here and basically put it inside of the while loop. And then just flip it. Now I could flip it by putting the exclamation point and put it in parentheses, but I'm just gonna flip it by flipping the sign. So that, while left is less than right. But I could have also put the exclamation point and put all in parentheses. Now I don't need any of this stuff. And if this ever happens, then I know that I have achieved palindrome. So I can just go ahead and say return true. And then when I know I have not achieved palindrome is when that basically is not true. So I can take this and basically put it in here and say if str is not equal to right, then I have to find at least one scenario where they're not equals, in which case I can pretty much immediately return false. And just move the left and the right to actually beneath the if statements like that, so it looks nicer. And then get rid of this. And that's pretty much it. That should work. As you can see, it does indeed work. So, but to get here, again, might have been hard to get here from like this one. So that is why this sort of intermediary version here is better. Actually, we didn't test it. We actually need to put a 4 here to test it. Okay, so now we actually ran it and tested on the code, which still works, but yeah. So again, baby steps. Trying to get here immediately might be tricky, but as you can see, this is sort of a good sort of stepping stone. Again, what I did here is, this is my base case. I just flipped it with basically flipped the logic backwards, but instead of flipping it and putting an exclamation point, all I did is just flip the sign inside. And then I went ahead and put the comparison and immediately returned false at that point. And then, of course, don't forget to update your parameters like you would in your recursive call. But there is, of course, no recursive call here because it will automatically go to the top in the loop. So it'll keep iterating. So yeah, in summary, today we talked about an example of recursions and how to convert recursive code to iterative code. It's not always easy. Most of the time it's not easy, I would say, but at least that gets you going. Again, why would you want to do that? Recursion is a lot easier to actually implement a problem from math, and so that's why you use recursion in the first place, but it's slower. So sometimes once you've implemented it in recursive code and it works fine in a prototype, but you want to speed it up, that's when you got to start figuring out how to convert code into iterative code. So I don't know what assignment you would get on recursion, to be honest. In the past, I would just give a bunch of small, like I give 2 assignments and I give like 5 functions that you need to do recursively. Things like check whether something's a palindrome or not. This time around, I'm not sure, but we'll find out together. And then, you know, I'm sure you'll do fine in it. So, but yeah, I don't think there's anything more. With recursion, the biggest thing that I can tell you is just practice. The more you do it, the more familiar you will get to it, and you'll start to pick up these sort of special tips and tricks on how to get things going with it. All recursive code can be converted to iterative code. There's only one thing that you need for some of it, and that is a stack. If you have a stack, which we'll talk about at the end of the semester, then any code can be converted. So there's no code that can run recursively you can't achieve iteratively. The other way around, I suppose it's possible in theory, but in practice it's not, because if you're running something that is running repeatedly for a long time, you can do this in recursive code, but it's going to segfault because it's going to run out of memory really quickly. So it's useless for things that are like constantly running. Like you have something in a loop that's like constantly monitoring a system. If you do that recursively, every time it's looping or recursing, I suppose, it's using memory. And very quickly it's going to run out of memory, and then the whole thing's going to crash. So while it is in theory possible, it's not practical for a lot of applications, which is why you want to convert it into iterative. So, well, hopefully this introduction was good. I suppose it's one of the hardest topics in 202 recursion, but it is not the last you'll see it. So definitely practice on your own time. Okay? So next time we will talk about linked lists, and that will pretty much take us into the next test. So I've sent out an announcement over the weekend, or actually, I think it was on Friday, whenever I did send the announcement. The next test is not going to be, it was going to originally be next Thursday, which would be the 12th. But some people, you know, the classes that go Monday, Wednesday, Tuesday, Thursday, and whatnot, they would have had it on either the 11th and the 12th. But the 11th is Veterans Day, so like there's no class that day. So we wouldn't be able to have a review. And then people that actually give out the test on Wednesdays would not be able to give the test on that day. So we didn't want to have like somebody give the test like on the 9th, and then on the 13th, the 12th, like to have a big gap between two classes. So it was a big mess. So we just said, okay, let's just move it back. So now the test is going to be 16th, 17th. For us, it'll be the 17th at 1 p.m., the official designated time or whatever, so that we know that everybody can make it. But we will have a review day probably on the day before, right? The Monday. So that's the advantage of that. Optional review day, I suppose. So will linked list be on a test? Whatever we cover next class will be slightly on the test. So like that was the same thing we were figuring out. We do want to put a question on linked lists, but we know that we're only going to get partly done with linked list. So we'll probably have something on the, introductory side of linked list. So you won't be coding like a doubly linked list, but there'll be questions on singly linked list, which is what we'll cover next time. So don't worry, there won't be anything asked that we don't cover. And if there was, we would just give you the points for that. So yes. Yes. Test is 2 weeks from tomorrow, I suppose. It just gets added to your grade regardless. It gets added on the category called extra credit, which just adds homework points there. So there's like, I don't know how many points there are right now given, but like, I'm assuming it's somewhere around 1,500, 2,000 points. I have no idea. It just gets added to that running total. So you can potentially, I've had people in the past, in the summer, end up with like 110% grade because they claimed the extra credit points, but they also did like pretty much perfect on each assignment, except for like maybe like 1 or 2 points lost here and there. So they ended up with more points than like the max. So it helped them on their test performance. But they also did really good there. So that's why they ended up with over 100% in the class. So that's pretty cool. The highest I've ever seen somebody end the class was like 116%. But that was, I think, in person, and the extra credit was in the tests themselves. So, but yes, yeah, it'll count. As long as you redeem it, it'll count. And then sometime in the next like 2 weeks, I will lower the redemption so that people that still have points but are not yet at the limit to redeem, they can still claim them. I don't want to do that yet because then we'll have like a billion different claims. I want to try to get as much of the max claim, and then I'll start lowering it. So just keep accumulating your points, I suppose. But claim them as soon as you can, so that, yes, like that. Because then I can actually do that now and not have to do like 50 of the small ones. But okay, anyways, this matches since we started out a little bit later because of the planes. Did anybody hear the planes? I didn't hear the planes. So yeah, last time it was extremely loud. Like I think they were flying right over. So like I ran outside and then it was even louder outside. It was kind of scary to see like military jets flying really low. I was like, oh, this is not a good sign. And this was April, so this was like mid sort of panic of like COVID-19. So I was like, oh no, did we get zombies now or what? Yes, DM me who you are because I don't know who you are. And there might be people that have similar names. Like I know we have 2 Patricks in the class, so like I definitely need the last name on that. So just send me a message on Discord, on Canvas, email. Just somewhere where, yeah, no, that was actually kind of scary when that happened. It was cool to see the planes, but then I was like, what's happening? I immediately Googled it and I found out, oh, it was like some air show. I was like, oh, okay, so it's safe. But yeah, because there was like formation of planes, so it's like it wasn't like just one random person. But anyways, all right then, I gotta go prepare for my next class. So I'll see you guys later on Wednesday. And linked list is coming, so get your assignments done. So thanks for watching, and I'll see you guys next time. Thank you for coming.